To explain this, let me first of all make a small change to the implementation for is month with 31 days. So let me go back to the birthday over here. Hypothetically, I'm going to change it back. So I'm just going to temporarily make this particular query ridiculously wrong. Okay. First of all, it's going to follow a very bad practice over here. It's not going to have this very nice post condition over here. Let's say we don't have such check, like such obligation on the supplier side. Okay, let's say we don't have this. So whatever result you might actually generate, it will just be considered as correct because there's no post condition check. It's as if the post condition is true. Let me remove it just temporarily. And also for this particular implementation here, let's say the supplier is really malicious. They always return the result false. Always. Okay, let me just compile this. Okay, it's a very malicious supplier over here. But now the question is, can our test case catch this error? Okay, let me run it right away. If I rerun the workbench system, if we see a red bar, that means our test case was good because it catches this error. If we still get a green bar, that means our test case was not good enough. Okay, that's the point I would like to illustrate to you. So let me simply say run. And run workbench system. Okay, hopefully you see what I'm doing now, right? I took out a very good post condition, and also I modified the implementation to be wrong. Run workbench system. We still get a green bar. So why is that? If we get a green bar, it's telling us everything is good, but we know that it's not good. So why don't we? So that's something that would deserve some explanation over here. Let me go back to here, and then we want to see why. For this particular test over here, why would I consider as a pass? Okay, let me go back here and see why. Okay, that's my iPad, and that's exactly the same block of code we have seen, and also with the hypothesis that we just said. This particular query always return false, always. And also it has no post condition which will constrain the output that's generated by the supplier. Okay, it's a very bad query practice, which hopefully you would never do this to me, hopefully. Okay, so now let's say, how can we explain this? Again, the main thing is about this, maybe thinner. The main thing is about this particular reassignments and also this particular reassignment here. So we are reassigning result 2 times, but only the last reassigned value counts. Okay, because it always return false, right? Always return false over here. So let's say for this particular call over here is going to return false. So that means result is actually going to be assigned to false. At this point, we should have already signaled an error. We should have, because result is already assigned to false. We should have, but it doesn't. But it's only the last reassigned value that counts. So let's do another one. So let's say over here, let me use pink over here. So now is month with 31 days. That's the second call. So over here is still going to return false, right? But now in this case, accidentally it happens to be the right answer. So not false is going to be true. So now result, the last reassigned value is true. That's why it's considered as a success. Okay. So what's really the issue here? The issue is we should have caught the error at this point over here. We should have, but we didn't. That's the problem. So that's why I said before, it would be very important when you got consecutive checks, when you got consecutive reassignments to the result Boolean value for your test Boolean test query over here, you should have intermediate assertions. So that's exactly what I meant. So we should have caught the error when the result is reassigned to false in the intermediate stage. Okay, really, that's the part we want to change. How do we change it? Let me show you directly. So you want to do some assertion over here. That's some new syntax you have to learn. Let me go back there, and then we'll simply do the following. Okay, what we should do is in the intermediate. So let me just put it here. For each intermediate reassignments to result, we must make sure it's not reassigned to false. Okay, let's do that. And the way to do a assertion is use a check assertion. So we say check and then space and then complete the end for you. Okay. So now what should we check? We should check to see whether result is at the moment true. You could have said simply say result equals true. That's legitimate. That's definitely possible. But I would say it's much neater if you simply say result. That's basically just equivalent because result is either true or false. In the case where result is actually true, it's going to return, well, it's going to pass the assertion and go to the next one. In case the result is actually false, which we already illustrated over here, in the intermediate stage over here, so that's going to cause the assertion to fail. In that case, the whole Boolean test case will be failure. Okay, that's what we expect to see. So now if we compile and then we run the workbench system over here, now we do see, but now you can see it's check assertion violated. And remember what I said before. I said before that in order for you to see what actually went wrong for debugging purpose, rather than running the workbench system, you got another option for ES testing. So now what for unit testing? What I can do is I'm going to say run. Let's see what happened. If I say run over here, because a check assertion actually occurred, so that means I have a stack trace over here. So the stack trace tells me exactly how it led me to this particular check assertion. So the top of the stack is simply where the check assertion occurred. So let's say this is in the context of test birthday, and it is this particular T static query over here. So try to get used to reading the information over here. It's very useful for debugging purpose. Of course, it's not only unique to iFlow Studio. In any programming IDE, they have such support as well. Okay, so now you can see we have a check assertion violated. It's exactly this point over here. And of course, if you really want to debug, a typical reaction would be rather than printing something to the console, you may want to set breakpoints and use debugger. But that's something we'll cover a little bit later. I just want to give you a little bit heads up reminder. Okay, let me stop here. So you can see in order to see how exactly the check assertion actually occurred, you cannot run workbench system anymore to find it out. You have to simply say run. Okay, it's a subtle details you must be aware of. Okay, so that's pretty good. So now let's see how can we fix. Well, if what we should do is we should fix it, right? Let me go back to birthday over here, and then let me move this guy. So now our test case is really considered as good because if really the compiler, if the supplier is really crazy and does something malicious, the test case will catch that. So that's a good test case. So let me just undo the change over here, but I'm just gonna wipe it out. So you have the recording, so you can always take some notes about what you should do. You can also take some notes on your code, but just make sure you put this version back. Control-Shift-K to remove the comments, okay? And also, I want to put this post condition back over here. Control-Shift-K. I want to show you one more thing that's also interesting, okay? Let's say compile over here. Okay, let me show you one more thing and think about it. So now let's say I put the post condition back, okay? It's a good post condition. However, I still have the wrong implementation. Let's say result is reassigned to false, okay? It's equally bad, right? It's the same bad implementation. Okay, so with this particular wrong implementation put back, I have a question for you. If I rerun the workbench system, are we going to get a green bar or red bar? And why? Specifically, if we go back to this particular test class over here, you can see we do have the intermediate assertion over here. You might think, yeah, we should have got a red bar as before, right? Because you can catch the error. But however, are we really going to get a red bar just because this check assertion was something earlier? Okay, that's my question here. Okay, pause the video and think about it. Okay, let me go back here. I got a little bit hints for you. Remember what we said in the lecture, week 1's lecture about how the contracts can be checked at runtime. Let me just recap very briefly. In order to execute this particular feature, first of all, we check to see whether its precondition is actually going to be satisfied, right? If it is, then we're going to execute the implementation for this particular feature. We're going to serve. And then in the post states, after the implementation has been executed, we're going to see whether every post condition is going to be satisfied, right? Okay, and then only after the post condition is also satisfied, that means we can actually flow. You can think about, for example, let's say to call this particular, make this particular call only after the post condition of this particular feature is satisfied, are we actually going to go to the check assertion, right? It goes sequentially in terms of the execution flow. Okay, hopefully that's enough hints for you. Okay, so before I rerun the workbench system, let's make sure, because remember previously I actually modified this back to wrong again. So I always make sure if to make the latest change to take effects, you have to recompile. Just don't forget, otherwise you might get some really weird behavior unnecessarily. Okay, so recompile, and then I'm gonna say rerun the workbench system over here. Previously I got a check assertion failure to cause a red bar, but now I still got a red bar, but that is actually a post condition violation. And which post condition specifically, the test report doesn't really show. So now we want to debug a little bit. And remember, we got two options for unit testing. Either you run the workbench system to see a report like this, but now we get a red bar, so we want to explore further. So that means we need to run to see the stack trace. Let's go back there, and then we simply say run. Let's see what happened. If we say run over here, and then we're actually going to see in the stack trace. So now we actually try to call this particular T static query. Okay, that's kind of the second last item in the stack. And then when we try to call this, and then by calling this particular feature over here, and then we call its month with 31 days. That's the last feature. However, when we try to check this particular post condition here, you can see result is always false, which means over here, okay, let me just make it a little bit larger for you. Result over here is false. Is false the same as M is actually this guy over here? You can think about this condition here is actually exactly the correct condition for the result to be true, but it's actually now false. So true and false, you actually got basically false. True equals false would be false. So that's why the post condition is actually violated. Okay, it's very important for you to think about why the post condition is violated over here, right? Because for the month, what's the month value right now? The month, you can actually look at the stack trace over here is actually its month, right? And then you can see under the objects panel over here, you can examine the values. So now you can see the M is of value 1. So M is equal to 1, so that will make the left-hand side directly just true. Is true equal to result, which is false? You can see result is false. Of course, it's going to be false. When you get a false over here, that's going to be a post condition violation. Okay, so now if there's a post condition violation, so now let me stop this over here. So that means in some way it's because our post condition is so rigorous, it's actually so correct. So even without the check assertion, actually check assertion goes even after the post condition. But I would say it would be still mandatory for you to always remember to put this intermediate check assertion, even though the reason is you cannot rely too much on every feature having a very strong and appropriate post condition. So for you as a tester, you should always put an intermediate check just in case. If you still go back to the original very poor supplier, which doesn't have a post condition even, in that case, the intermediate assertion will save you. Okay, so really trying to make sure you understand the flow of the story I'm trying to tell you. Okay, so now finally, I'm gonna put this back to the original correct implementation over here. Okay, so that's exactly correct implementation. And then also you can see we got intermediate checks for the reassignments of the result. So you will see this pattern here over and over when we write other cases later. Okay, and then recompile and make sure we still get a green bar. That's very important. Okay, that's good. So now what we have done this particular test over here for its month with 31 days. So that one is already done. So what we need to do is do one more query, but that can be done very quickly, and then completing invariants. Let's do that. So let me go back to birthday over here. So we already got this particular correct query over here. Why don't we just create another one just by copy and paste? Let me copy this guy here, and then let's paste. Okay, so now let's call that its month with 30 days. Okay, so now is M a month with 30 days, right? It's still going to take an integer returning a boolean. Okay, and month should still be within 1 and 12. Okay, and now this guy over here, okay, let me just get rid of this. Let's stick to this particular pattern over here. So now what should be the array contents be? But now, since now we talk about 30 days, right? So why don't we say By the way, it cannot simply say not month that has M because you are excluding the possibility of February. Okay, just wanted to tell you. So now what we should do is we should really say 4. You see the idea, but hopefully I'm not getting this wrong. 4, 6, 9, and also 11, right? So these are the 4 months. In which case I'll get 30 days. So it's going to be either 4 or 6 or 9 or 11. Okay. Okay, so now compile, so everything's good. I will give you one little exercise here to do. Okay, so now I will put test birthday over here. So now I'll put a to do. So if at the end of the tutorial series, you need to make sure you complete all the to dos. Okay, I would say to do over here. Write a Boolean test query and add it as a test. When I say add it as a test, that means you're going to add it over here precisely, right? Make sure you follow the same syntax, okay? It will be a nice practice for you. Write a Boolean test query on. So now we did is month with 31 days already. So now why don't we do is with 30 days? Okay, you can do something very similar, or you can try to test more cases with more intermediate assertion checks. So that will be a nice exercise for you. Okay, so that'll be a to do. Okay, let me go back to the invariants for the birthday, right? So remember, don't lose the big picture. The reason that we actually went to actually develop these two static queries were because we actually wanted to make the valid combination more elegant. Okay, so now why don't we go back to this particular invariant here and do it? Okay, so now I'll still keep the original one over there. So that one, just to remind you, we are really trying to do something that's more elegant. Okay. So now under this particular tag, we're going to have a single Boolean condition. Think about what's going to be the logical structure. We're going to say the following. Okay, if the month is actually with 31 days, in that case, the day should be between 1 and 31. If the month is with 30 days, so that means the actual day for the birthday should be between 1 and 30. Otherwise, we are really talking about February. In that case, the day should be between 1 and 29. Let's say we don't have to worry about leap year. Okay, let me write it down over here. So let's say is month. It's gonna be in the whole thing is gonna be a Boolean expression. It's month with, let's say, 31 days, and then so now we're gonna refer to the attributes, right? Remember, in the class invariants, you have to refer to the relevant attributes. So month over here. So again, month is referring to whatever the month value is for the instance that we are talking about for the context objects. Okay, so month over here. So now that implies 1 less than or equal to. I will have one little question for you at the end. Let's just write it down. 1 less than or equal to day, and day less than or equal to 31. Okay, either this is true, or, well, actually, so this must be true, which means if it is actually 31 days, that implies it should be between 1 and 31. Okay, and also the following should be true. Something very similar. Okay, why don't I just copy this and paste it? So now if that should be, if that's 30 days over here, and that should be 30. Okay, and finally we are just missing one case. We talk about all the months except for February. And now over here we can say month is equal to 2. That implies, let's say, 1 less than or equal to day, and day less than or equal to 29. Okay, everything will compile. However, this is actually not going to work logically. Okay, I'm gonna explain to you. For those of you who might be interested in knowing about the answer yourself before I give that to you, here's a hint: precedence of the logical operators. Okay, pause the video if you want to think about it, but let's now switch to iPad, okay, to tell you why. If I switch to iPad, so it's really about which operator binds the tightest, or which operator binds tighter than others. Okay, so now, this is the example we from iFlow Studio. But now let me explain the principle over here, right? You might have seen this maybe in your previous programming course or maybe in a larger course. The highest precedence will be the conjunction operator, and the loosest or the least tightest operator would be the if and only if. Okay, and then we got in between and the or and the implies. Okay, so now let's say this without any parentheses. This is going to be the principle of applying them. For example, if I say P1 or P2 and P3, if that's what I write without any parentheses, it would be as if that I put the parentheses over here, because and binds tighter than conjunction disjunction or over here. Okay, hopefully you have seen that kind of issue previously in your logic course or programming course. So now if I apply this knowledge over here, so now here there's no parentheses over here. So now what would that be equivalent to? Apparently I got implication over here, for example. I also got conjunction over here, right? So now conjunction binds tighter than implication. So that means it's as if I actually will get this particular Boolean expression over here. You can think about this is like a P1. And you can think about, for example, let's say this particular guy over here is actually P2. Okay, P1 and P2. Think about that's P1 and that's P2. And then conjunction binds the tightest. So it's as if we put the, beg your pardon. It's as if we actually put the parentheses over here. So now this guy will be evaluated as a whole. But that's completely nonsense logically, right? Even though it will compile. That's not what we intend to do. So what do we intend to do? What we intend to do is to brackets in a different way. So now I would say in this case, so the main message from this particular example is whenever you're using a mix of logical operators, you should always be careful. If you really know what you're doing, if, for example, if the blue highlight is really what you meant to do, be my guest. That's fine. However, if you're not too sure, always use parentheses to actually do your evaluation ordering. That's intended. Right, but apparently in this case, I'm pretty sure it's actually wrong. So I'll go back to iFlow Studio. Hopefully you see the issue here. So let me go back here. And then what I should do, I should use brackets to help me. Okay, I put the brackets over here, right? So this is going to be evaluated as one conjunct. And then this is going to be the second conjunct over here. And then this will be the third conjuncts. Okay, so these are the three conjuncts for this particular invariance. Okay, if you like, there's another way to split it. Okay, if you like. Let me just make, okay, I'll just mention that on the paper and then you can try if you like. Okay, so now let's say this. If you have a tag, either tag precondition or tag postcondition or tag invariance, right? So let me put it this way. Let's say just say you say invariance. If I have some invariance over here, okay, under invariance, if I say invariance over here is a tag, which is an INV. If I say P1 and P2 and P3. Let's say this is one case. Logically, it would be equivalent to as follows. It would be equivalent to, of course, I gotta make sure it's spelled correctly. If I simply say invariance over here, let's talk about an alternative scenario. What I can do is I can split P1, P2, and P3 into three different invariants separated by new line. So new line character in this case is more like a conjunction, not disjunction. If these are disjunctions, you just cannot do this, okay? You'll only for conjunction. So what you can do instead, you can say invariance 1 is P1, invariance 2 is P2, and also invariance 3 is P3. So that's the second version, and these two versions are completely equivalent. Okay, so what would be the advantage of doing number one? Apparently for number one, it's actually just a single invariance, and then it's just nicer, just a single line, right? Depending on how complex P1, P2, and P3 are. However, the second version over here, as you will see as you get more experience, the second version is nicer because so now you're splitting into different tags. So now you got different traceable tags you can actually do when you do the testing as well debugging. So, for example, if it's actually P1 that's if that's actually P2 that's violated, so invariant 2 tag is going to be shown on the stack trace. On the other hand, if P2 over here is violated, or P1 is violated, or P3 is violated, doesn't matter which one, you will always get just in INV as a tag violation, so you cannot really tell which one actually got violated, because for the conjunction, as long as one of the conjuncts get false, the whole thing get false, right? It's a little bit experience sharing. So I would say which one you actually use is completely up to you. I'm just explaining to you what the difference is, but logically they are really equivalents. Okay, that's about for this part over here. So we have seen how to develop this particular invariance. So I'm going to explain how we can test the creation of an object for the birthday later.